Hello students, today we are doing questions from magnetic field. Actually it's from force, magnetic field force questions. Right, the question will appear very soon. Let's start doing the very first question. Let's try it and then let's go through the video explanation. Alright students, I hope you have tried the question. So this question, they are telling an electron goes upwards vertically with a speed of 2 in 10 to the power 6 meters per second, and the gap between the plates is 3 millimeters, and there's this 600 volt potential difference across the parallel plate capacitor. Right, actually this question, there's a combination between electric field and the magnetic field as well. Right, so basically this is a magnetic field question, but you need to have electric field knowledge here. Right, so these kind of a question we have in our level, so it connects two lessons together. Right, so basically what actually happens is, let's say here we have positive, here we have negative plates. So normally what happens is the electron will be attracted towards the positive terminal. Right, so we need to, there will be a electric force towards this direction. So how do you find the electric force? You should know the electric force equation, F equals EQ. Right, so let's apply that equation here, F equals EQ. Right, so then here E is not given, electric field intensity is not given, we are only given the potential difference. So from the potential difference we should know the equation how to find electric field intensity. That is E equals delta V over D. Right, knowing that, let's apply it into the equation. So the force will be delta V over D, that into charge, that is electric force. Right, so there's no deflection when it is moving upwards, that's what they are saying, that is the requirement. Right, so then there must be another force towards this direction, that's why it balance off. Right, remember that equilibrium of forces will come, it plays a major role when doing questions. So that's why I was telling that in my other previous actually videos, you have to be really good with equilibrium of forces in that lessons. Right, remember that if you are not good with it, you have to do questions from those as well. Right, here now there will be a magnetic force towards this direction. So what is the equation for magnetic force? A moving charge in a magnetic field, F equals BQV. Right, BQV. Right, then we charge Q and Q will cancel off. Of course you can see it, Q, and they ask us to find the value of B. So B equals delta V over D divided by velocity V. Right, so delta V, potential difference, is 600. Right, and then divided by the separation, 3 into 10 to the power minus 3, and the velocity of course 2 into 10 to the power 6. 3 into 2 6, 6 cancel off, so 10 to the power minus 3 and 10 to the power 6, that's 10 to the power 3 then. So it's 100 upper here 100, so into 10 to the power minus 3, let's do the simplification here, it's 0.1 Tesla. Right, that's the answer for our first question. Right, moving into the second question. Right, here I hope you have tried the question now. So this rod actually that is going downwards. Right, so it is coming downwards, so force downwards, it has to be mg sine 30. These things you must know from mechanics questions. Right, then if it is moving downwards with a constant velocity, so if it is moving downwards with a constant velocity, that means there's no acceleration downwards, no resultant force. That means in upwards direction we need to have another force that is equal to mg sine 30, is F value. Right, so F, that must be equal to mg sine 30. Right, So this F upward force is exerted by the magnetic field we have here. So what's the equation for magnetic field for a rod? It's BIL. Yes, you have to take the angle as well, right? So B, that's a question, right? Yes, that's what they're asking. What is the find the magnitude of the magnetic field, right? So let's write the equation. B magnetic field, actually it's in this direction. I hope you can see it. And force, actually it's in this direction, right? Okay. So magnetic field, that must be exerted in it perpendicularly. It must exert in perpendicular direction. So let's say this is the direction of magnetic field and this is the direction we need to consider, the perpendicular direction. So if it's B is here, angle theta 30 here, right? Okay, right. So we need to find the angle actually, right? I hope you understand. It's 90, it's 60 here. So again, here it's 60, 60, 60, and here 30 angle. We take the component, it's B cos 30, right? Into the current I, yes, current I, and length L, P, right? Magnetic force, that must be equal to mg sin 30, right? So they're asking us to find B. So let's subject B. B equals mg sin 30 divided by IL and cos 30. Here of course sin 30. I hope you can see sin 30 divided by cos 30, that's tan 30. Tan 30 1 over root 3, right? Moving into our answer, B equals mg divided by IL and 1 over root 3, right? So this is our answer for the second question. Right. We are moving into the third question. In this question, they are telling two parallel wires, very long, and current flows in two opposite directions, and they're asking us the attraction or repulsive force, the value of it, right? So actually what happens here is magnetic field is created by one, let's assume one magnetic field is created by one parallel wire, and that must be created on this wire. We have to find the direction, of course. So let's put right hand rule, right hand grip. So current flows downwards and the magnetic field moves in here and it comes out from here. So it dots we have here. Correct, right? Yeah. Here in, comes out from here. So it comes out from here. The value of magnetic field, of course, you should know the answer. B equals, yeah, mu naught I over 2 pi r. So r is the separation, the distance actually we consider, right? So we have the value of B, and we need to find the value of F, magnetic force. F equals BIL. Actually the length of the wire is not given, so we have to consider 1 meter length, right? Let's apply the equation now. So then F, so F equals BIL. B we have found here, mu naught I over 2 pi r. B, I the current 5 amperes into L length. Let's take 1 meter here, right? So mu naught value 4 pi into 10 to the power minus 7, that is given, and I current, it's 5 mu naught I, and again BIL, here it's again 5 we have here, and divided by 2 pi r, again 0.5, right? We have all the values. Let's do the simplification now. 4 pi, 4 pi, 2 pi, 4 pi cancel off. We have 2 here, and 2 into 5, of course 10. 10 into 10 to the power minus 7. Oh, you cannot see it here. Let's move it up here. So let's do the simplification again. 2 into 10 to the power minus 7, and into 5 into 5 divided by 0.5, right? Yeah. 2 into 5, 10. 10 to the power minus 6, of course. And 5 divided by 0.5, it's 10 again. It's 10 to the power minus 5 Newton. Right, we have the answer. Now they're asking whether they attract or repel each other. Right. We need to apply right hand. No, it's left hand, right? Force, left hand rule. Right. So magnetic field on this into the paper, out of the paper. Yes, left hand. Yes, the force going upwards, the current goes upwards, okay, and force the field in this direction, so it's other direction side, it repel. Yeah, repulsive force, and 1 into 10 to the power minus 5. That's our answer. Students, I have given you a couple of questions from magnetic field. Try those questions and then go through the playlist. Even from other fields, try the questions, go through the playlist, and you will find new questions. Try the questions and then go through the video explanation. You will find something new for sure.